Okay, this last example would be a classic word problem that you would have to use or solve using differentials. So here we're given that the side of a square is measured to be 10 feet with a possible error of plus or minus 1/10 of a foot. So basically what that means is if 10 by 10 square tiles are being made and they're manufactured, there's a possibility that there could be some error, like they would be off, meaning you would have one that's 9.99 or a little bit greater than like 10.1, so it just depends. So here the first part says use differentials to estimate the error in the calculated area. So it's the error in the calculated area. So the first thing I want to look at in part A is I need to say, okay, I'm finding the area of a square. So the area of a square is s squared. This is where implicit differentiation will come into play because we will take the derivative of the area in relation to the side. So this is dA ds is equal to 2s, which would be ds ds, but we're not going to write that. So then if we want to figure out the error in the area, it means I need to find the differential for the area, meaning the difference. I'm going to move this over here. So we have dA is equal to 2s ds. Okay, so the calculated error in the area, meaning the possible change in the area, is equal to 2 times a side, which is 10 feet, times the possible error. So it's plus or minus 0.1 feet. So when I multiply, this is 20 times 0.1 is going to move that decimal back. So my error in the area would be plus or minus 2 square feet. Okay, meaning the area of that tile is going to be off. Okay, so that's what this is. In part B, it says estimate the percentage error in the side and the area. So there's two problems here. But what we need to understand is we need to determine the relative error. So for those of us that either don't know or have forgotten or are not sure, relative error is the error divided by either the total area or a total circumference. Okay, so it just depends. So you might need this at another time. Okay, so we need to figure out the percentage or relative error in our side. So if we're looking for the side first, we're going to do this one first. This is part B. Relative error in our side, okay, is the error for the side, which is the possible change, divided by the total area or the total of the side. What is the measurement or the length of the side? So in this case, ds is plus or minus 0.1 divided by, that's this, what a side is, which is 10. So if I take 0.1 and I divide it by 10, this is what I get, 0.01. However, they want the percentage. Okay, so then this you multiply by 100, which moves the decimal to the right. So this is going to be plus or minus 1%. So this is the error for the sides. So then to figure out the relative error in the area, okay, you would do the same thing, except now this is going to be dA over A. Now we could do this a couple different ways. So we know that dA is 2s ds right here, right? Over, if we want to put this, this is s squared. Okay, if we reduce, this is 2ds over s. Okay, and then we have 2 times, well, first of all, ds over s, this right here is 1%, so we already have this. So this portion right here is 2 times plus or minus 1%, so then the area is going to be 2%, plus or minus 2%. So we have a 2% relative error in the area. It's plus or minus 2%. So again, there's a lot of different ways you could do this, because you could figure out what the area is, so it just depends.